Hello YouTube. This series will examine the different approaches to what is known as folk psychology. This term has been defined in many different ways, but I will use the term folk psychology to refer to our capacities for explaining and predicting the behaviour of others by ascribing mental states to them. We assume that other people have mental states such as beliefs, desires, emotions, pains, moods, and so on, and attributing these states to others is part of what allows us to understand them and to engage with them effectively. Basically, folk psychology is the central part of our capacity for social cognition, our capacity for dealing with other people. To give a very simple example, suppose we observe Frank get up out of his chair, go to the kitchen and get a piece of chocolate cake. Why did Frank do this? Well, it seems fairly trivial. Frank desired some chocolate cake and he believed that there was chocolate cake in the kitchen. We can offer more detailed explanations. So we might say, well, either Frank has no countervailing desire, such as the desire to lose weight and hence stick to a diet, or Frank's desire for chocolate overpowered his countervailing desire to eat healthily, or whatever. But even the basic explanation invokes mental states. It invokes desires and beliefs of Frank. Now, traditionally, the assumption is that the psychological states of other people are unobservable. So we don't come to the conclusion that Frank desires chocolate cake by directly seeing inside his head. Instead, we make an inference based on his behaviour. So how do we make that inference? How do we arrive at the conclusion that other people have mental states? This video will focus on the account given by the theory. Essentially, the theory claims that folk psychology is a theory, similar in form to scientific theories. So that's why it's called the theory, because it's the theory that folk psychology is a theory. So on this view of folk psychology, on the view that folk psychology is a theory, the thought is that folk psychology postulates various theoretical entities. So these are the mental states, beliefs, desires, hopes, dreams, and so on. These entities can't be directly observed, and what the theory does, the theory of folk psychology does, is it consists of various platitudes that relate these entities to behaviour. So platitudes like, if X desires P and believes that Q is a means to P, then other things being equal, X will do Q. Or pain tends to be caused by bodily damage. Or people in pain tend to want to relieve the pain. Or people who are angry tend to be impatient. So folk psychology connects behaviour with hidden mental states, and that allows me to infer mental states on the basis of observed behaviour. When we understand other people as having mental states, we apply a theory to their behaviour. We understand others by employing a theory. Now, an important thing to note here is that obviously we're not always consciously aware of this theory, nor do we have to engage in any complex calculations as you might with a scientific theory. Nevertheless, theorists suggest that we are ultimately relying on a tacit theory when we infer mental states from a person's behaviour. And folk psychology does seem to share a number of features with theories. So for one thing, theories are sort of abstract. They go beyond observations. This is clearly the case with folk psychology. The relevant observations are simply observations of behaviour. Folk psychology extrapolates from behaviour by positing internal mental states. Furthermore, theories posit causes and laws. Again, this is true of folk psychology. Mental states are caused by certain things and they have certain effects. I've already given examples of the law-like relations that folk psychology proposes, such as pain tends to be caused by bodily damage. Theories allow us to make predictions. They support statements of the form, if X happens, then Y will happen. Now, prediction is one of the central roles of folk psychology. We use it to make predictions of how other people will behave. If I know your mental states and personality traits and so on, then I can make useful predictions about how you will respond to various events. So I can say that if I hit your hand with a hammer, then you will you will experience pain and become angry with me, and so on. Finally, theories strongly influence what pieces of evidence or data we consider salient or important. Here is a photo of a galaxy cluster. I draw your attention to these white streaks, sort of curved white streaks that you can see in a few places in this picture. Now, looking at this without any understanding of astronomy, you might not consider these streaks to be particularly important. Indeed, they sort of look initially like imperfections in the photograph. I mean, maybe the streak is produced by some problem with the instrument. But the theory of general relativity puts these streaks in the spotlight. This photo shows gravitational lensing. The enormous mass of this galaxy cluster bends space-time, and these streaks are actually distorted images of galaxies lying billions of years behind the cluster. The point is that the theory of general relativity makes certain pieces of evidence, certain observations, salient. With respect to folk psychology, it arguably makes things like eye movements salient. A person's eye movements can provide a great deal of information about their internal states. So, in many respects then, folk psychology does seem to be something like a theory. Of course, a prima facie worry about the theory is that in other respects it doesn't seem theoretical at all. Indeed, folk psychology seems to be more practical. It's connected with day-to-day activities. It seems to involve abilities and skills rather than theoretical knowledge. It's embedded in social practice. Perhaps folk psychology is more like a theory when you're trying to work out a person's motivations, and when somebody does something odd you might ask, why did she do that, and then you begin forming hypotheses. But generally speaking, it really, it only seems to be a theory in a metaphorical sense. But the primary response to this is that it depends on a sort of naive view of what theories are. In fact, theory and practice are very closely linked. Theories can be deeply intertwined with our daily lives. Not every theory is detached and abstract. To give a few examples from Paul Churchland, just consider the importance of geometry in the working life of a carpenter, or the role of music theory in the day of a jazz musician, or the role of medical theory in the day of a doctor. Once a person becomes, for instance, a skilled musician, she will probably stop thinking of music theory in explicit terms. Instead, it will just become internalised. And this is most obvious in the case of something like musical improvising. I'm not a particularly good musician, but I have played instruments before, and when you improvise on an instrument, you just sort of enter a kind of flow. You don't think explicitly about music theory, even though obviously music theory must be playing a significant role in sort of constraining what you're doing. As a beginner, you learn a theory, but then as you develop your skills, the theory becomes internalised and it becomes second nature, and so it doesn't have to be explicitly considered. And that is how folk psychology is. We are all, for normal adult humans, folk psychology is just second nature. We sort of do it, we just do it habitually. So, if folk psychology is a theory, how exactly do we develop this theory? There are essentially two options. First, we might hold that folk psychology is largely learned, so children are born without any tendency to, without an innate tendency to develop folk psychology, but they work it out as they age. Second, we might hold that it's largely innate, that it's an adaptation. Our minds have evolved to at least dispose us towards the development of the folk psychology theory. Of course, the development of folk psychology, just like the development of any trait, must involve both genes and environment, but different views will emphasise one of these more than the other. It seems clear enough, for example, that a trait like the eye has an evolutionary history, whereas one's hairstyle is a product of culture and learning. So the question is folk psychology more like the eye, or is it more like your hairstyle? Well, closer to the hairstyle side is Alison Gopnik, who holds that folk psychology is pretty much entirely learned. What's more, according to Gopnik, the child develops folk psychology in pretty much the same way as scientists develop scientific theories. A good quote from the Stanford Encyclopedia of Philosophy sums this up. It says, "The cognitive mechanisms which drive the child's development of folk psychology are exactly those mechanisms which drive the adult scientist's development of scientific theories." When we are young children, we are all developing theories about the world. One of these theories concerns how other people's behaviour, and that's where we develop folk psychology. A privileged few of us are able to continue applying the same methods once we get older, and that forms the institution of the sciences. So the theory of mind in the child is basically exactly like a scientific theory. I just need to make one terminological note. Gopnik refers to this idea as the theory. In this video and in philosophy of mind in general, the term theory refers to the claim that folk psychology is a theory. No assumptions are made about where the theory comes from or how much it has in common with scientific theories. So if you do read about this elsewhere, just be aware that the phrase theory is used in different ways. Gopnik uses it to refer specifically to the idea that folk psychology is learned exactly the same way as scientific theories are developed. So just bear that in mind. That's not the usage that I will be adopting. So anyway, what are the arguments for Gopnik's view? Well, the basic thought is that where did our ability for doing science come from? I mean, science as we know it has only been practiced for a few hundred years. It certainly, we didn't evolve to do science. We did evolve, however, to learn about the world. Young children have various powerful and flexible devices for learning. So science, it would seem, simply co-opts these devices. We haven't evolved with anything new in our cognitive repertoire, as it were. Science just co-opts the devices that we had always used, even when we were children. So we should expect that children develop theories just as in the same way scientists do. Perhaps a more persuasive argument is that the acquisition of folk psychology follows the same pattern as the development of scientific theories. So how does scientific theories develop? Well, in the sciences, what generally happens is scientists will propose a theory and then they will derive a prediction. If the prediction is successful, that's all good. If the prediction fails, we have an anomalous observation. Now, the initial response to anomalies is often dismissal. You can maybe run the test again or assume that there was some problem with the equipment or whatever. But if the anomaly is persistent, eventually ad hoc hypotheses will be given in order to deal with it. An example of this was how the orbit of Mercury deviated from the predictions made by Newtonian mechanics. This was back in the 19th century. The orbit of Mercury it kind of deviated from the Newtonian predictions. Scientists proposed the ad hoc hypothesis that there must be another planet nearer the Sun, which was exerting an additional gravitational force on Mercury. This proposed planet was called Vulcan, and there were many unsuccessful attempts to find it. If anomalies accumulate, or if the anomalies can't be dealt with by ad hoc hypotheses, then a new theory may be proposed. By the end of the 19th century, Newtonian mechanics suffered numerous anomalies, and this led to Einstein's theories of special and general relativity. Then there's a period of intense experimentation, testing the new theory against the old. Now, Gopnik thinks that infants display the same pattern when they develop theories. Infants have theories that are used to make predictions and that are revised in the face of new evidence. If the theory held by an infant makes a failed prediction, the infant will come up with an ad hoc hypothesis to deal with the failure, and then if failures accumulate, the infant will eventually scrap the original theory and replace it with a new one after intensive testing. As an example of theory change in young children, which doesn't really concern folk psychology, but Gopnik thinks that almost all theories are similarly learned, consider how children understand motion and object permanence. I choose this example just because it provides quite a simple illustration of Gopnik's view of infant cognitive development. So, by about 6 months, infants can follow the trajectory of an object that disappears behind a screen. However, suppose you have 2 screens with a gap in the middle. The object goes behind one screen, it doesn't appear in the gap, and then it comes out from the other screen, like as in this diagram. To an adult, this would look rather curious, but at 6 months, infants are completely untroubled by it. Furthermore, a 6-month-old infant will not bother searching for an object that has been hidden, even if they see it being hidden. If you take their favourite toy and put it under a cloth, they won't search for it. They'll act as if it's disappeared. By 9 months, they're rather more developed. If an object fails to appear in the gap between the screens, they will look back to the first screen. They will look behind the first screen. So they seem to be aware that the object coming from behind the second screen must be a different object. Furthermore, if an object is placed under a cloth, they'll search for it. However, at this age, infants exhibit a rather strange error known as the A not B error. Suppose the infant observes an object being hidden and then retrieved from under cloth A several times. The infant then observes the object being hidden under cloth B. The infant will persistently search under cloth A rather than cloth B. So what should we say about this? Well, Gopnik, of course, thinks that this pattern can be explained by assuming that the infant adopts and tests various theories. The initial theory is that an object out of sight has simply gone. Of course, this theory can't explain how objects that pass behind other objects consistently turn up again, so later, by about 9 months, they develop a rather more sophisticated theory, something of the form, for an object that has gone out of sight, the object is at the place or trajectory at which it disappeared. It is behind the occluder when it's out of sight, and the fact that it is behind the occluder is what makes it invisible. So that the fact that the object is behind something else is why you can't see the object anymore. This is a useful theory. When an infant sees an object go behind a screen, this theory gives the right answer, and it also leads us to expect that if there's two screens with a gap in the middle, then you should see the object pass through the gap. When the object goes, when the object is behind the screen, you won't see it, but then you'll see it when it's in the gap, and then you won't see it when it's behind the second screen, and so on. However, this theory has trouble dealing with certain standard situations where an object disappears and then reappears in a place that can't be determined from the visible trajectory of the object alone. For instance, suppose the baby throws its toy out of its crib, and so the toy is out of sight, and then later the toy ends up in the toy box. That's because the baby's mother moved it there, although of course the infant doesn't always see the other person move the toy. To deal with this situation, the infant adopts an ad hoc hypothesis along the lines of some objects have a sort of natural place. When these objects go out of sight, they will reappear in their natural place where they have consistently appeared before. So the same toys will consistently reappear in the toy box, even if when they first went out of sight, they were nowhere near the toy box. Now consider the A not B error. The object is consistently shown to appear under cloth A, so the infant assumes that cloth A is the object's natural place. That's where it lives, as it were. So when the object is taken out of sight by being placed under cloth B, the infant draws the prediction that the object will appear under cloth A again. So Gopnik's picture is that the child has a certain theory of objects. It's a useful theory, but it faces certain anomalies. The child then proposes an ad hoc hypothesis to account for these. The ad hoc hypothesis is that objects will reappear where they have consistently appeared before. Eventually, of course, this itself accumulates anomalies, such as when the infant looks under cloth A and doesn't find the object there. And by about 12 months, the standard view of motion and object permanence is developed. And Gopnik thinks that the development of folk psychology exhibits the same kinds of patterns. Now, the obvious problem with this sort of argument is that all Gopnik has really done is offer an interpretation of the pattern of development. But there are many other interpretations available, which you can find if you just look up the A not B error. You will find different interpretations of it. And this is in general the case when it comes to infant development. There'll always be many other interpretations on the table. Still, we do have to accept, I think, that Gopnik's view that infants develop theories in the same way that scientists develop theories, it's at least a possible view of it's plausible enough, I suppose. Now, there are several objections to Gopnik's infant scientist theory. First, there are problems with Gopnik's argument. For one thing, just because the acquisition of folk psychology and the development of scientific theories follows the same pattern, this doesn't entail that they are the same kind of thing, or that they are underwritten by the same cognitive mechanisms. Water and liquid mercury exhibit the same patterns with respect to waves and convection currents and things like that, but they're obviously not the same. In any case, there are also plenty of differences between folk psychology and scientific theories. For one thing, as we've already noted, folk psychology is almost entirely tacit, whereas scientific theories are consciously developed. Another difference that may be of significance is that scientists operate within institutions that insist on very strict rules and regulations. Scientists work with other scientists, and they do so according to fixed rules. Neither is the case for infants. Infants must develop their theories largely on their own, and they don't have any institutional rules to speak of. Second, it's very questionable that scientific change actually does occur in the way that Gopnik suggests. I won't go into this here because it would really require a whole series to explore properly, but there are many different accounts of what the scientific method is, and of how science develops, and of how individual scientists work, and so on. Indeed, it may be that different sciences develop in different ways. There are a lot of alternative views on this matter. It's just worth bearing in mind that Gopnik's view of scientific development isn't accepted by everyone. It is controversial. Third, even assuming that Gopnik is right about scientific change, notice that Gopnik's picture of scientific change applies to the scientific community as a whole, not to individual scientists. Indeed, individual scientists are often quite dogmatic. They're often very resistant to abandoning theories in the face of failed predictions. This is the source of Max Planck's famous quote that science advances one funeral at a time. So that this kind of pattern of, okay, the theory makes predictions, the predictions fail, ad hoc hypotheses are developed, anomalies accumulate, eventually new theories are proposed. That pattern applies to science as a whole, but it's not really clear that it applies to individual scientists. So in fact, if folk psychology develops in individual children, in the way Gopnik suggests, this would imply that the development of folk psychology in children is not much like the development of theories by scientists. Infants don't work like scientists do. So there are several problems with Gopnik's argument, I think. A second objection is the poverty of the stimulus argument. Basically, the idea is that folk psychology is learned very rapidly. By the time children are just 4 or 5 years old, they will know pretty much the whole framework of folk psychology, despite having very little explicit instruction. But folk psychology is also very rich and complex. So the poverty of the stimulus argument is that children are simply not exposed to enough data about behaviour and mentality to arrive at the highly sophisticated theory of mind that they soon develop. The stimulus, or the evidence that is relevant to folk psychology that children are exposed to, can't possibly be enough for them. It can't be enough in itself for them to be able to acquire folk psychology. This is a popular argument, but I'm not going to go into too much detail on it. There are two questions which make it very difficult to evaluate. First of all, how much evidence is actually provided by the environment? How much evidence is a child exposed to? I mean, the answer there will require quite extensive studying of child development, but broadly speaking, the answer is surely that infants are exposed to an enormous amount of evidence, since infants will be interacting with other people for several hours every day, and almost all of the evidence that almost everything they do in their interactions with other people will count as evidence relevant to the theory of mind that they develop. So actually they're exposed to an enormous amount of data. Now the second question is, how complex is folk psychology? And actually I would say arguably it's not that complex at all. I mean, when we're adults we can elaborate it in more sophisticated ways, but if we think about the basic elements of it, the basic concepts of belief, desire, pain, emotion and so on, I'm not sure that's a particularly difficult or sophisticated theory. So, I mean, the problem with trying to run a poverty of the stimulus argument is going to be, well, how do we quantify the amount of evidence that would be necessary to develop folk psychology versus the amount of evidence that the infant is exposed to? And I think that quite plausibly we could say that the infant is exposed to an enormous amount of evidence, and actually we don't need that much evidence anyway when it comes to folk psychology, because folk psychology just isn't a particularly complex theory. So, it's, as I say, quite a popular sort of argument, but I'm not really sure it's that persuasive. A third objection, which I think has a bit more bite, is that all normal children pass through common developmental stages, and there's evidence that this is almost entirely independent of culture. Now, if folk psychology is learned like a scientific theory, why do all children arrive at the same theory at about the same age? As an example, consider Wimmer and Perner's famous article, Beliefs About Beliefs, which proposed the now famous false belief task. In this task, here's just one example. There are many different variations on this, but let's say a child is watching two puppets. The child is watching basically a puppet show, and involving two puppets. The first puppet places a toy in a particular location, for example, under a red box. So the first puppet comes with a toy, puts the toy under a red box. Then it leaves the room. A second puppet comes in, and it takes the toy from under the red box and moves it to a different location, say under a blue box. And the second puppet leaves. Now then the first puppet comes back. The child observing the play is asked, where will the first puppet look for its toy? Will it look under the red box, or will it look under the blue box? Now by the age of about 4, the vast majority of children will correctly judge that the puppet will look for the toy under the red box, even though it's actually under the blue box. The majority of younger children will say that the puppet will look for the toy under the blue box. They think that the puppet will look for the toy where the toy actually is. So at about the age of 4 or 5, children are able to attribute false beliefs. They become able to understand that another person's perspective is different from their own perspective. So they're able to understand that the perspective of the first puppet, from the perspective of the first puppet, the first puppet's going to expect that the toy is under the red box, because that's where it placed the toy, even though the toy is now under the blue box. So the children aged 4 or 5 are able to understand that they know the toy is under the blue box, but the first puppet believes falsely that it's under the red box. Younger children seem to lack a concept of belief, or at least they don't know that beliefs can be false, that beliefs can misrepresent the world. Younger children, to quote Gopnik, she actually sums it up quite well. She says, they seem to understand the mind largely in terms of perceptions and desires, and they think that perception is always veridical. As long as you are, as it were, perceptually pointed at the right part of the world, you will know everything there is to know about it. The false belief experiment has been performed in a variety of cultures, and it often delivers the same results. Children pass it around the age of 4 or 5. For instance, in the article Synchrony in the Onset of Mental State Reasoning by Callahan and colleagues, false belief tasks were given to children in Canada, India, Peru, Samoa and Thailand. In all of these cultures, children pass the false belief task by about 5 years of age. Other folk psychological capacities also seem to exhibit a standard developmental pattern. For example, by the age of about 3, children understand the seeing leads to knowing principle. This can be demonstrated by a task in which a child is shown a film of a box, where one person looks at what's in the box, another person merely touches what's in the box. 3-year-olds will understand that the person who looked in the box knows what's in there, whereas the person who merely touched it probably doesn't know. So 3-year-olds sort of understand the significance of sight as providing knowledge of the world. As another example, consider emotional causation. By about 4 to 6 years old, children understand that emotions can be caused both by events that happen to you, but also by what you think is happening or what you think will happen to you. So Frank is happy because he has been given some chocolate cake, or he's happy because he thinks he will be given some chocolate cake. In the latter example, Frank's happiness is caused by his beliefs, even if these beliefs are wrong and he's actually not getting any cake. Children aged 4 to 6 are able to understand that beliefs, even false beliefs, can lead to emotions. Finally, researchers gave children second-order false belief tasks. These tasks require reasoning about embedded mental states. For instance, what Frank believes that Vincent believes. So Frank believes that Vincent believes the toy is in box A, but actually the toy is in box B, or whatever. Children pass this task by about 6 years of age. Now, all of this is rather curious on Gopnik's theory. Why do all children develop folk psychology and not some other theory? And why do they go through common developmental stages? Indeed, this is especially curious given that folk psychology can be elaborated in different ways. Why don't any children spontaneously develop, for example, Freud's notion of unconscious desires? The idea of unconscious desires is quite a useful concept when it comes to explaining behaviour, but there just doesn't seem to be much individual variation in the development of folk psychology. All children learn basically the same theory and at sort of the same times. It's not really what we would expect if they were learning this theory in the same way that a scientist develops a theory. How might Gopnik respond? Well, the first point is that a lot of the uniformity might be explained by the fact that all children are exposed to essentially the same evidence, and they're exposed to an enormous amount of evidence. In science, of course, evidence is difficult to come by. Generating evidence for scientific theories often requires painstaking observations and advanced high-level equipment. Generally speaking, an individual scientist will make only a few observations that are relevant to his or her theory. This is also the case for more sophisticated theories of minds. More complex theories take much more effort. So it's not surprising that some concepts, like the notion of unconscious mental states, were only developed by scientists. On the other hand, as we noted earlier, children are exposed to evidence relevant to basic folk psychology for hours every day. And even in very different cultures, much of this evidence is the same, simply because human minds have many similarities even across cultures. Second, we can challenge the claim that there are universal developmental stages by arguing that actually there is variation. So Gopnik cites a study which shows that children with more siblings develop an understanding of false beliefs earlier than children with fewer or no siblings, despite the fact that children with more siblings actually tend to, they don't score better on tests for general intelligence or anything like that. Gopnik suggests that this is because children with more siblings are presented with a greater amount of evidence concerning other minds. Another example is given by Penelope Vinden in her article Hunin Quechua Children's Understanding of the Mind. She gave false belief tasks to Peruvian children aged 4 to 8. All of them, even the 8-year-olds, performed poorly on the false belief task questions. So there is evidence that there is some cultural variation. But on the other hand, I mean, we might wonder whether we should expect more variation if folk psychology is learned like a scientific theory. An important thing to note is that these studies only concern the timing of when a certain capacity develops. But this doesn't show that the capacity is learned. So think of puberty. Puberty is clearly innate, it's not learned. But puberty occurs at different times in different cultures due to just different environmental influences. It depends on how well nourished you are, for example. So what is problematic for Gopnik's theory is that all children pass through the same stages, even if there are slight variations in timing. There seems to be a certain set developmental trajectory, even if in some children it takes longer than others, and that's hard to explain on Gopnik's view. A final problem is that there's perhaps a more serious problem posed by false belief tasks, and this is pointed out by Peter Carruthers. Prior to the development of the concept of false belief, how could the child scientist compare an older theory with a newer one? How could they judge that their current theory is inadequate? Judging that your theory is inadequate relative to a newer theory would seem to require judging that your current beliefs represent the world falsely, whereas the newer theory would represent the world correctly. So it seems to require a concept of belief and false belief. It's difficult to see how you could develop a theory in the same way as a scientist develops a theory without a concept of false belief. So that's all for today. As you can see, there are certainly some problems with the idea that folk psychology is learned like a scientific theory. In the next video, we'll look at the attempt to explain folk psychology as an innate capacity, an adaptation, a product of our biological evolution. But that's all for now. Thanks for watching.